Have you ever wondered what the heck is a vector database? I am Felix,
And I am Ruby.
and today we are about to dejargonize a technology that's become a core component for many AI systems, the vector database.
That sounds technical. Is it like a regular database that stores text or numbers in rows and columns?
Not quite. A vector database is a specialized data store designed to find information by its meaning rather than by an exact match of keywords.
So it goes beyond just searching for specific words. How does that work?
Exactly. Think of it like a really good librarian. If you ask for books about overcoming failure in business, the librarian doesn't just look for that exact phrase in the catalog.
Right, they would understand the concept. They would know which books are about business resilience or learning from mistakes, even if they don't use those exact words.
That's the perfect analogy. The librarian knows which books sit near that idea on the shelf of meaning. A vector database is essentially the digital version of that librarian's intuition.
Okay, so it's a database that understands concepts. But how does it store information if not as text?
In general, the tone stores text. It stores mathematical representations of content. These are called vectors. This allows the database to find items that are conceptually close to each other in a mathematical space.
So it's all about finding things that are similar in meaning, not just in wording. That's a fascinating way to approach search.
It really is. And the process for how it achieves this is quite elegant. It starts with a special AI called an embedding model.
An embedding model. What's its role?
In general, the tone is to translate content into that mathematical language we were talking about. Each piece of content is passed through this model, which converts it into a long list of numbers. This list of numbers is the vector.
So the meaning is captured in a numerical pattern. What happens when I actually search for something?
In general, the same process applies to your search query. It's also converted into a vector. The database then looks for the stored vectors that are mathematically closest to your query's vector.
That makes sense. It's finding the most similar number patterns. But searching through millions of these complex vectors must be slow.
You'd think so, but they have a clever solution for that. To stay fast, vector databases use something called approximate nearest neighbor algorithms.
Approximate? So it's not looking for the absolute perfect match.
That's right. These algorithms are designed to sacrifice a tiny amount of accuracy to gain massive improvements in speed. It's a trade-off that makes searching through enormous datasets almost instantaneous.
So it's all about speed and efficiency. It sounds like the database is doing some really smart thinking to make all these connections.
That brings up a really common misconception, and it's an important one to clarify. People often think the vector database itself is intelligent or that it truly understands the content it stores.
But doesn't?
No, it does not. At its heart, it's just a search engine for similarity. It's incredibly fast and efficient at finding number patterns that are close to each other, but that's all it does.
So if the database isn't the intelligent part, where does that conceptual understanding actually come from?
In general, the intelligence lives entirely in the embedding model, the tool that produces the vectors in the first place. That model is what determines how meaning is translated into math.
I see. So the quality of the search results depends completely on the quality of that initial translation into vectors.
Exactly. If that model is weak or poorly matched to the content, you'll get poor results. The database will faithfully return vectors that are mathematically similar, but to a human, they might feel semantically wrong or nonsensical.
So if the database is just a highly efficient search tool for meaning, where does it really shine? Why is it so important for the AI systems being built today?
It matters because this capability is the backbone of many of the most useful AI features. For instance, it's essential for something called retrieval augmented generation, often shortened to RAG.
Retrieval augmented generation. What is that exactly?
It's a technique that allows AI models, like chatbots, to ground their answers in a specific, reliable set of documents. This prevents the AI from making up information and ensures its responses are based on a curated body of knowledge.
I see. So it gives the AI a specific knowledge base to draw from. This must also be what powers more advanced search functions.
Exactly. Vector databases are the engine behind semantic search, which understands a user's intent instead of just matching keywords. They're also crucial for the recommendation systems you encounter on streaming services and e-commerce websites.
That makes perfect sense. They're finding products or movies that are conceptually similar to what I've liked before.
Precisely. When you put it all together, vector databases are providing the long-term memory and factual grounding for many of the most important enterprise AI applications being built today.
That brings us to the end of the episode. If you think we helped you de-jargonize the term, make sure to subscribe and follow us wherever you get your podcasts.
See you on the next episode.